Hi guys, Terry here again. I'm going to be working the some of the questions from the July 2021 paper today. All right, so this is question 5, and in this question they said 100 students were surveyed on the amount of money they spent on data for their cell phones during the week. The table below shows the results as well as a midpoint of each class interval. Using the table, determine the modal class of the amount of money spent. Okay, so whenever they ask you for, they said the modal class, right? Now your mode corresponds to your highest frequency. Now notice here, they said number of students, and this really represents the frequency. Now, whenever they give you a table in the exam, you need to try to interpret the table. Now, what this means is that between the first interval here, right? Now they said more than 50, but less than or equal to 60. So that's going from 50.5. Well, actually, no, this will just be, 50.5 to 60. And our frequency here is 7. It means that 7 students spent money on their data on their phone between $50 and $60, right? So we're looking for the modal class. So we're looking for the highest frequency here. Now your highest frequency is 31, right? Now the answer is not 31 here, but your interval here that they want is going to be between 70, right, and 80, right? So this is what they're looking for here. That's my, so this here, this is what we need to look at, right? Part B now, they said calculate an estimate of the mean amount of money spent given your answer to 2 decimal places. Now, they've given us data. This is group data in a table here we're looking at, right? And what they want us to do is to calculate the mean. Now, in order to calculate the mean, now they've already worked out the midpoint for us, and they've given us the frequency. So what we need to do, we need to draw up a new column, and we're going to call that column XF. Right? We're going to take our midpoint and multiply by our frequency. That's what we're going to do, right? So let me just clear up this a little bit here. So all right, so we need to, like I said, a new column, right? And it's going to be called our XF column, right? Let me just draw a line here. Right, so this is what you actually have to do in the exam. Okay, so what we're gonna do, we're gonna say 7 multiplied by 55. You're gonna get 385. So here is 385. Then we're gonna say 11 multiplied by 65. You're gonna get 715. Then we're gonna say 31 by 75, sorry. That's gonna be 2325. So this here is 2325. Then 29 by 85. You're gonna get 2465. And then 22 by 95. You're gonna get 2090. So this here is 2090. Now, in order to calculate the mean, right, what we need to do, we need to find the sum of my frequency, which is the sum of the how many students we have. Now, they told us we had how many students? Did they tell us? All right, so they said 100 students, but let me just double check to make sure we have that. So it's 7 plus 11 plus 31 plus 29 plus 22. And yes, we're getting 100. So we have 100 students here, right? Then we need to find sigma XF. Now in maths, when you see the word sigma, right, when you see the symbol, this means to sum, right? So what I'm doing, I'm summing the column. So I'm gonna add all these guys here in order to figure out sigma XF. So that's 385 plus 715 plus 2325 plus 2465 plus 2090, right? And what I'm going to get here is 7980, 7980, right? All right, so we have sigma xf and we have sigma f. So the question says calculate an estimate of the mean. So the mean, right, the symbol we use for the mean is x bar, is equal to sigma xf divided by sigma f, right? So sigma xf is the total that we got just now, 7980. So this is 7980 divided by sigma f, which we know is 100 students, right? So you're dividing that by 100. So therefore this, and they said mean amount of money, so we should put this in dollars. So this is going to be 79.80, right? So 79.80 is our mean, right, for this data they've given us here. Now the next part here, Damien reports that the median, so now they're asking us about median now. Median amount of money spent is $84. Explain briefly why Damien's report could be correct. Now, median, right, is our middle data, right, when all the data is arranged in ascending order. Now, if you go to the table, whenever they give us data in a table, the data is already arranged in ascending order. Now, here's how we're going to do this. You have 100 students, right, which means that your median, right, really supposed to correspond to my, now 100 is an even number, right? So therefore, you don't have an exact middle, right? Because your data will go like this, 1 to 50 students, and then from 51 to 100 students, right? So there's no exact middle. So therefore, your middle student is somewhere 50.5, right? That's where my median lies. So let me go back here. So this is what we're saying. We have 100 students, so 1 to 50, right? That's the first half of our data. Then 51 to 100, that's the next half of our data. So therefore, our median really supposed to correspond to 50.5, right? Now that's where our median is supposed to lie. Now we need to go to the table now. That is students we're talking about here. So what we're going to do, this is 7 students here, right? When we move to the next interval here, we have 11 students. So that's 18 students already. Now, when we reach here to 31, so that's 18 plus 31. So we have 49 students up until this point here, right? So therefore, we're not at 50.5 as yet. So we need to come into this interval here, right? So my 50.5 students actually lies in this interval. This is where our median lies, right? So your median is somewhere between 80 and 90. We don't know exactly where, but that's where it's supposed to be. Now, let's see again what they said in the question. They said, Damien reports that the median is $84. So let's see. So he's kind of correct, because $84 is actually lying in this interval here between 80 and 90, right? So let's say something about this, right? So there are 100 students. So they have 100 students here, right? Right? So the median student is 50.5, right? So therefore, we need to say median. Now I just showed you how we added up the numbers, right? So the median must lie in the interval, right? So let's go back to the table. Which interval was that? 80. So you're going from 80 to 90. Right? So the median must lie in the interval 80 to 90. right? So Damien could be correct. Right now, if you're wondering what I did here, right? What I was doing, I was finding essentially the cumulative frequency up until this point here, right? That's what I was doing here. Now the next part here is about probability, right? So it's a two-way contingency table. So they give us some information about the mode of transportation to school for 100 students. So we have walking, cycling, driving. We have boys and girls, right? Complete the table by inserting the missing values. Now this table is relatively easy to complete. If we look at this horizontal row here with boys, you have 15 walking, 14 driving, and you have 48 in total. So therefore, to figure out this cell here, all we need to do is to add the 15 and 14 and subtract that from 48, right? So it's 48 minus, we're going to add up the 15 plus the 14, and what we're going to get here is 19, right? Now, what else can we work out? We can work out our totals as well, right? I can work out the cell here just by adding 19 plus 18. You're going to get 37. Then what do we need here again? So in terms of the totals, right, to figure out this cell here, all I need to do is to take 100 minus 48, and I'm going to get 52. And then to get this cell here, well, there are two ways you can work this. Either we just take 23 and subtract 15, right? Or we can take 52 minus 18 and then subtract 26. So I'm just going to take 23 minus 15. So I'm going to get 8 here, right? So this is our table, the complete missing table. This is easy to mark here in the exam, right? Now let's see what else do they want here. A student is selected at random. So we're talking about probability. The probability that he or she is being driven to school on that day. So we didn't specify boy or girl, but we want to see how many are driving to school. Now in terms of the total number of students that we have, right? We have 100 students here, right? So therefore, our probability, right, that he or she was driven to school, right? So we need to see how many students were actually driven. So the total number of students who drove to school would be this figure here, right? 40 students in total would have driven to school, right? So this is 40, right, divided by the total number of students, which is 40 over 100, right? So this could be reduced, right? And if you reduce this, you're going to end up with 2/5, right? So you can write your answer as a fraction, right? Or you can put your answer as a decimal. So you can say 0.4, right? So these are, this would be my answer, 0.4 or 2/5, right? The next part here, the third part, one of the girls is selected at random. So they're giving us some kind of condition here, right? One of the girls is selected. What is the probability that she does not cycle to school? So probability that a girl does not cycle, right? Now she doesn't cycle. If you go to the table here, if you are not cycling, that means you would have walked or you would have driven, right? Now we're concerned about our girls here. So we're concerned about this here, right? Which means that our total, right, is going to be 52. So in that, in this probability, the bottom part here has to be 52, right? Now we need to look at the table and see how many students did not cycle, how many girls did not cycle. So we're looking at this 8 here and this 26, right? So 8 and 26, we need to add up those two figures. So this is really 8 plus 26, right? And that's going to give me 34. So this is 34 over 52, right? And this could be reduced, right? You can write this as 17 over 26, right? So if you put 34 over 52, you should still get it right. 17 over 26, because you could reduce the fraction, right? So that takes care of question 5. Now let's move on to the next question, which is the measurement question, right? So let's look at the measurement question here now. Now, CXC did bring a question like this a few years back, maybe 2016, 2017. It was a question about a silver box, right? Which is very similar to this one here. So Farmer Brown makes troughs to feed animals, right? Using wood that has a thickness, right, of 5 centimeters as shown in the diagram. The troughs are rectangular, based, open at the top, right, and have external dimensions of 300, 900, and 160, right? Now, with this particular question, you need to be careful in terms of how you are visualizing this, right? You need to be careful. So the first part says, show by calculation that the internal capacity or volume of the trough is this figure, right? Now, I always tell my students, you should be happy when you get a question like this, because they've given you what the answer is. So what you need to do, you need to essentially use the information that we have in order to get this as your answer, right? Now they want the internal volume of this this trough, right? So my internal volume, right? Now this is a cuboid here. Now what we're concerned about is the inside of this, right? So if you, let's see if I were to draw. Now we're looking at the thickness. Remember, you need to cater for the thickness of the wood, right? So I'm just going to draw some lines here so you all are a little clearer as to what's happening, right? So that's what's happening here. On this side is the same thing. Right? So we must factor the thickness of the wood. So therefore, if we're looking at the internal dimensions here, this here, right? Remember, you need to cater for the 5 centimeter thickness. So you have a 5 cm here. This here is 5 centimeters. Then on this side here is the next 5 centimeters. So therefore, we're looking at the internal dimensions. So this is really, so 5 and 5 is 10. So this here is actually 290 centimeters, right? That's the internal, let's call that the width, is 290. On this side here now, this is not going to be 190 on the inside, because you need to remove 5 cm and a 5 cm. So therefore this is 180 centimeters here, right? Now that's fine, students will get that part. The part that they won't get is the height, right? The height now of this thing here, what they may want to do is to subtract 10 centimeters from the 160, right, from this figure here. But you can't subtract 10 centimeters because only the base of this container is 5 cm thick. It's an uncovered container, right? So therefore, all you need to do is to remove 5 cm from the 160. So this dimension here is going to be 155 centimeters. So therefore, the internal volume of this container is going to be length by breadth, or length by width by height. So my length, let's use the length as 180. So it's 180 multiplied by 290. 290. Multiplied by my height, which is 155, right? Now, hopefully I didn't make a mistake, but let's see. So it's 180 multiplied by 290 multiplied by 155. And look, I'm getting the answer that they asked for. So I'm getting 8091.123 cm cube, right? And look, that's what they asked us to prove. So we've done that. Right? So we've proven what they asked us to do. That's the answer. Right? Now let's look at the next part here now. They said calculate the volume of the wood needed to make the trough. So here's what's going on here. You know what the internal volume is, right? The capacity of this box. You just work that out. So if you want to get the volume of the wood, all we need to do is to use the external dimensions to find the total volume of this cuboid, right? That is using the 300, the 190, and the 160. Use that to find the total volume occupied by this box, right? And then we're going to subtract the internal part in order to figure out how much wood you need, right? So your internal volume internal volume right? They also call it the capacity, right? That figure was 8,091,123 cm3, right? That's my internal volume. Now the external volume, right? Again, it's a cuboid, so you have to go length by breadth by height, or length by width by height. So what we're going to use here, I'm going to use my length as 190 by 300 by 160. 190 by 300 by 160, right? So that is going to be 190 by 300 by 160. And what I'm getting here is 9,120,000. So this here is 9,120,123. Right, so 9,120,000, right? So therefore, volume of wood all right, we're going to take our external volume, which is the 9,120,000 minus 8,091,123. So minus 8,091,123. 8,091,123. Yeah. And what I'm going to get for my volume in this case here is 1029,123 cm3. So that's the volume of wood that I actually require. So what I did, I took the external dimensions and I worked out the volume, and then I subtract the internal volume that we got before, right? Now the last part of the question, they said Farmer Brown must paint the internal surface of the trough, given that 1 gallon of paint. Right, so you have to be careful with this question here now, this part, right? So he want to paint the internal of this thing, right? That's what you want to do. You want to paint the internal of this. So therefore, what we need to do, we need to factor, or we need to figure out all the faces on the inside. So that's this face here, this one on the inside, this one on the inside, and the base, right? So that's 5 faces we need to account for, right? So that's the first thing we need to understand. It's 5 faces, right? We need to take into account. So let's look at the base. The base might be the easiest one, right? So the base of this container here, right, is going to look like this. Now I'm looking at it from the top, right? So let's look at the dimensions here. So we're looking at the internal dimensions here. So therefore, this here is going to be 290 cm, right? That's my base we're looking at here. And this here is going to be 180 cm, right? So this is one area that we need to work out. So this here is my base, right? That's my base. Then let's say we're working out the internal face, let's say on this side here. So that one is going to be, so it's going to be a rectangle, right? But let's make sure we have the correct dimensions. So we're looking at the internal dimensions here. So again, right, that internal dimension is going to be 180 cm, right? That is this length here on the inside, but then we're going up here as well, right? So instead of 160, this is going to be 155. So this is 155 cm, right? So this is our next area we need to work out. But the thing is, this area on this side here, and this side is going to be the same, right? So we have to multiply that by 2, right? I'll just put it right. So we need to multiply this by 2. Okay, I have 2 faces that look like that. Then let's look at this face in front here now. So that face in front here is going to look like this. So that here is going to be 290 centimeters, right? So that's 290 centimeters. And then we need to look at the height of it, which in this case is going to be 155 again. So that's 155 centimeters here, right? And in this instance here, we have to multiply this by 2 because you have 2 faces which are identical. So it's times 2, right? So what we're going to do, our total surface area on the inside, that's what you're working out. So let's write on that. Our total surface area. Alright, so let's look at this. This base is 290 by 180. So the base is 290 multiplied by 180. Right? And we're going to add that now to 180 by 155. Right? So it's 180 by 155. But remember, you need to multiply this by 2. Right? You have to multiply that by 2. Plus, again, the second part we have to work out by 2. So that's 290 by 155. So this here is 290 by 155. Right? So let's work out each part separately. So 290 by 180, that's the base we're working out here. That is 200 plus, so this will be 180 by 155 multiplied by 2. You're going to get 55,800. So this here is 55,800 plus, then we're going to take 290 multiplied by 155, and then we multiply this by 2. So you're going to get 89900. And now we're just going to add up all these surfaces now. So 52,200 plus 55,800 plus 89,900. What I'm going to get here is 197,900 centimeters squared. That's my total surface area on the inside. Now we haven't answered the question as yet. Question says 1 gallon of paint covers this amount here, right? So 1 gallon covers that amount. Determine the total amount of paint in liters, right? So we need to write a statement along those lines. So we know that 280,000 cm squared, right, is covered by 1 gallon, right? But the thing is, they want the answer in liters, right? So what we need to do, we need to make a conversion here, or change the statement at least. So 280,000 cm squared is covered by 3.79 liters. So you put in 3.79 liters here, right? So we know that our total surface area is this, 197,900. So therefore, right, 197,900 cm squared, right, is actually covered by, and what I'm going to do, I'm going to take the 197,900, I'm going to multiply it by the 3.79, and I'm going to divide that by 280,123, and what I'm going to get here is multiply by 3.79 divided by 280,123. And what I'm going to get here in terms of liters, it's going to be 2.68 liters. Right? Now what you could have done is worked out for 1 centimeter squared first if you want to, right? So you could have done this. You could have worked out the amount of paint required for 1 cm squared, which is simply going to be the 3.79 divided by the 280,123. Right? You're going to get a really small number, right? You're going to get 0.0000135, right? That's what you're going to get in terms of liters, right? And then all you would have had to do is to take that number and multiply by the 197, right? So my answer here is 2.68 liters. All right, guys. So this is my solution for question 5 and question 6. I just put out a reminder that my new Form 4 classes start in August 2021, right? It's not a summer class. It's at the start of the syllabus. right? That's for maths, add maths, physics, and chemistry. All right, guys.